Hello, Dr. Bill here. Today we're going to look at a variety of things that are very important in standardized tests. And if you find this lesson valuable, please do subscribe to the channel, hit the like button, the bell icon to be notified of future videos, and kindly share the video with anyone you know who could benefit from it. Okay, so let's get into it. We have here a triangle ABC. The base is 6, and here for angle A, we see that this is the Greek letter theta. This is often used in reference to angles when some sort of SOHCAHTOA thing is going on. So let's see here. First of all, the figure is not drawn to scale, so we cannot trust the diagram as reliable. And it says, in the triangle pictured above, triangle ABC has a base with a length of 6. If the tangent of theta equals the square root of 3, what is the measure of AB, which is the hypotenuse? Again, just the side opposite the 90-degree angle. Okay, there's a way to do this instantaneously, but you have to see what's going on. I will go over that, but let's say you don't see what's going on and we need to kind of do this step by step. So let's get into it. Okay, the first thing is that they're telling us the tangent of theta is equal to the square root of 3, right? And if we think back and just quickly write SOHCAHTOA, okay. So here, the tangent of an angle, in this case theta, is equal to the opposite side over the adjacent side, right? So we're going to write here tangent of theta equals opposite over adjacent. And we know that the adjacent side is 6. Again, adjacent just means next to. So the side next to this angle is 6, so we can put that as our denominator. We don't know what the opposite side is, so we'll put x, but we do know that here the tangent of this theta, right, of this angle, is equal to the square root of 3, right? So we know basically that x over 6 is going to equal the square root of 3. So let's solve for that. So we get x over 6 equals the square root of 3. And then we don't want to know what x over 6 is. We want to know what x is, which is here this opposite side. So we simply multiply both sides by 6. Again, whatever we do to one side, we need to do to the other. These 6's cancel, and we're left with x equals 6 times the square root of 3, right? So here we say 6 square root 3. Okay, now we need to know what side AB is. Well, we could do that using the Pythagorean theorem, right? So let's give this a try. Again, the Pythagorean theorem we'll do down here is a squared plus b squared equals c squared, right, when we have a right angle. And here we need to remember with the Pythagorean theorem that it doesn't really matter which side we call A and B, right? We could call the base A and the height B or vice versa, but C is always going to be the hypotenuse. It's the longest side, opposite again the 90-degree angle. So let's work this. We got a squared, let's call that 6. So 6 squared plus 6 times the square root of 3 all squared equals c squared, right? Okay, 6 times 6 is 36, right? So we put 36. Okay, now what would 6 times the square root of 3 be, right? Okay, well, 6 squared is 36. The square root of 3 squared is 3, okay? Because if we have here the square root of 3 squared, right? Then the square root sign and the exponent cancel, and we get 3. Okay, so this is going to be equal to 36 times 3. Okay, 3 times 6 is 18. 8 carry the 1. 3 times 3 is 9, and 1 is 10. So that would be 108, right? And this is equal to c squared. Okay, 36 plus 108 is 144. So 144 equals c squared. And once again, the square root of c squared would equal the square root of 144. Again, the square root sign and the exponent cancel, so we get c equals the square root of 144, which is 12. Therefore, this hypotenuse is 12, okay? And our answer is B as in boy. Okay, now here, what would we do, again, differently in order to get this more quickly and efficiently? What we need to remember is that there are 2 special right triangles that come up repeatedly on standardized tests, right? Okay, the one that is not related to this problem, but you need to know, let me just draw this, is the isosceles right triangle. So it's 45, 45, 90, right? And whenever we have a 45, 45, 90 triangle, the sides exist in a very specific proportion. Now you probably remember that equal sides will exist opposite equal angles. So since this is 45 and this is 45, whatever this side is also what this side is, right? And then the hypotenuse is always going to be equal to the side times the square root of 2, okay? That again is not related to this. The one that is related to this is the 30, 60, 90 triangle. Okay. So here, let's say again that this one is 60, this is 30, and here the sides are always going to exist in the proportion of side opposite 30 is side, the hypotenuse is going to be 2 times that side, and then the side opposite the 60 will equal this side times the square root of 3. So again, for 30, 60, 90, we have side opposite the 30, 2 side for the hypotenuse, side times the square root of 3, opposite the 60-degree angle. And what did I notice here? I saw that, okay, this adjacent side is 60. As soon as we saw here that the tangent of theta would equal the square root of 3, we kind of did this calculation. And we saw this was 6 square root 3, that would tell us immediately that we have a 30, 60, 90 triangle, because again, we have side square root 3. So right away, we would know the hypotenuse is going to be 2 times this side, right? 2 times the side opposite the 30. So right away, we see here that it is 12, okay? So I hope this lesson was helpful. Again, if it was, please subscribe to my channel, hit the like button, the bell icon to be notified of future videos. Please share, and this is Dr. Bill. We will see you on the next video. Thank you.